Hello and welcome to the session. In this session we will be discussing about the von Neumann architecture. In fact, this is the main or pioneering architecture in the history of computer science, and this architecture is still continuing in some form of or different form. We will be discussing about this particular architecture in major details. But before we start this particular session, let us discuss about the basic objectives of this particular session. The basic objectives of this session are to define the basic components of a computer system, to define the functions of various components of the computers, and basically highlighting the von Neumann architecture under these two categories, and thirdly to define the basic hardware terminology which is associated once again with the von Neumann architecture. So we will be basically focusing all our attention to the von Neumann architecture. The basic thing which we have to define here first is what is a computer. Before we discuss about anything, it is always essential that we define about what a computer system is. Computer is a general purpose programmable electronic machine having two principal characteristics. Now remember two things here. Number one, it is an electronic machine, so it will be dealing mainly with electronic components. Number two, that it is a programmable general purpose machine in the sense that it can be utilized for a multiplicity of application without changing the basic nature of the machine. So how this particular thing is possible? There should be something by which it should be possible, and once again in the slide we have for you response to specific set of coded instructions in a well-defined manner. That means here is a machine which responds to given set of instructions in a well-defined coded instructions which comes to a computer. They are responded to and some kind of responses are attained out of that particular machine. Number two, it can execute a pre-recorded list of instructions which are also called program, and this particular term you will be hearing very often, program, which is basically a coded set of instructions, maybe in high level language, and for the basic von Neumann architecture context it is the low level language context of the computer. Now we have defined about the program, but what is a program? A program is basically a set of instruction. But what is an instruction then? Well, in that sense an instruction is a binary coded command. Remember, binary coded command for computer which is designed for a specific task which is assigned to the computer, and those tasks may be arithmetic and logic operation which is to be performed by some part of the computer or some component of the computer which we would like to explore in more details. Looping and decision making. Now that is a very important operation which is performed by the computer, and we would like to explore more about these concepts. Transfer of data as well as transfer of control. So all these things we would like to explore further. But once we say that these are the basic operations which a computer need to perform, then how these operations are to be performed by a particular computer system. Now for that we need to explore how an instruction needs to be executed by a particular computer system. For that there need to be certain steps to be followed for execution of an instruction, and those steps are: first get the instruction itself, decode that particular instruction, then get the set of operands on which the instruction is to be performed or the given operation is to be performed, perform the desired operation and communicate the results back to you. But how these operations will be performed? If all these operations are to be performed, they are to be performed by a set of units or set of components which are existing in a computer. So let us look into those components. The first of all, you see, the topmost thing which you are encountering in a computer is the instruction code. That means these are the instructions which are to be supplied to the computer by some means. We don't know what that means may be, but our guess may be that may be an input-output device. After all, those are the devices which are meant for inputting data into the computer system. The second thing is then these instructions are then supplied to an instruction interpreter, okay, whose job mainly should be to do the decoding of operation, as we have said in the second operation of ours, decode the instruction. Okay. Now, if that is so, the decoding of instruction is to be done by a particular unit which at present we are terming as instruction interpreter. And the role played by the instruction interpreter will be to accept the instruction codes and issue a set of control signals. Okay. Now, all those control signals basically are pointing to that a given set of operation or just a given operation is to be performed by something called instruction processor. And what that instruction processor will do? That instruction processor will take data from the computer. As we have said, the third step of our program of our execution step was get the operands, and that is what this particular data is indicating here, and that is that data will be coming in, the control signals will be supplied by the instruction interpreter, instruction processor will perform the given operation onto that particular, and that operation will be specified by the control signals, and that operation, once the operation is being performed, the results will be generated and those will be communicated to us. So this is the rudimentary or the basic design of any computer system. So what are the components which will be needed? As I told you, the very first component which will be needed in this particular category is the input-output component, which will be responsible for inputting data as well as instructions into the system. Then we also need a sort of instruction interpreter, and we need instruction execution unit. But are these components sufficient for any computer system, or do we need something else for any computer system? Let us look into some of the typical instructions or some of the typical things which we follow in our life. One of the common example in this category is if then else category. The second example in that category may be the looping kind of constructs. Now all these kinds of things tells us that a program execution need not be very linear in nature. If that is the case, then what is in addition we need from the computer system? And that particular thing I would like to define as the memory of the computer. But why do we need memory? There are basically three basic reasons for having memory into the computer system. The first one is, since we are dealing with non-linear paradigm, that is programming paradigm, and I have already given example for that. The second one is, an operation on data may require more than one data values in a predetermined or predefined sequence. That means we need not take just one data value, but a series of data values which are to be stored in some sort of temporary storage, so that at the time of execution there are no delays and all the things can be specified at that same moment. And third, and most of all, speed of input versus the speed of processing unit. That the speed of input output, if I am doing any humanly input output, it is always slow, it is always slower than what we expect. and therefore what we find that CPU has to wait a lot before an instruction can be performed, before the decision can be taken, and that is why in the von Neumann suggested that we need more than 2 components for a computer system, and these components are but before we define these components, let me define what are the key concepts behind von Neumann architecture. I have already defined the basic 3 components, but in addition I would like to define the key concept behind the von Neumann architecture. The first key concept behind the von Neumann architecture is that the data in instructions, we were talking about them separately, yet data and instruction can be stored in a single read-write memory, and that is the first concept which was put forward by von Neumann. He said, why can't we use the same memory for inputting data as well as instruction to the computer, and maybe the data outputs are put to the same memory, and later on they can be displayed through the input-output devices, or maybe the input-output devices may be utilized beforehand to input data and instructions, then they are recorded into the main memory, and then later on the operations and other things are performed by the computer. The second key concept given by von Neumann was the content of memory addressable by location irrespective of the type of data stored into it. Now, what kind of data von Neumann basically talked about? There are 2 basic kind of data which are stored in the memory. One, the data itself, which may be numeric, which may be ASCII or any other kind of data, but that is one kind of data. The second kind of data which can be stored into the memory is instruction. So basically pointing to the previous thing. However, the most important thing over here is the addressable locations. The basic objective over here of saying addressable location is that if you that each location can be addressed separately in a von Neumann architecture, and that is why you might have heard about a term called RAM, that is random access memory, which basically points to the addressable content of any memory location, that it can be addressed, any memory location can be addressed at random. And how it is going to be possible? It is possible only because we will be providing certain addresses to each location in the memory. And the third concept which was put forward by the von Neumann was that unless and until specifically told, an instruction, sequence of instruction will be executed in a sequential manner. Now that is very, very important conclusion, and that is in fact very, very important suggestion put forward by von Neumann, because that led into the design of certain registers which we will be discussing, and the name of that register is program counter, which just keeps track of what are the instructions to be executed next. Okay. Now before we discuss about an instruction execution through von Neumann architecture, let us summarize that what should be the components of a von Neumann machine. So according to von Neumann, the following components should exist in a general purpose computer, and these components are the main memory. And what is the role played by main memory? It is basically for storing data as well as instructions. The second unit is going to be central processing unit. If you remember our previous slide, what we have said over there, and a command or instruction interpreter followed by instruction follower or executor. Now these are the basic 2 components put into a single unit called central processing unit, and these 2 components are called arithmetic logic unit, which basically performs the operation, the arithmetic as well as logic operations onto the given set of data, as well as the second unit is called in that is control unit, and the basic role played by the control unit is that it basically understands an instruction and supplies the requisite control signals to arithmetic logic unit as well as to memory, so that the given set of instruction can be executed as per our steps, as I had given you in one of the previous slides. The third component, which I have already highlighted, is the input and output system, and the basic role once again played by input output system will be to supply information to the computer at the requisite times whenever computer needs it, maybe through users interaction or maybe at a sort of global interaction when we put a complete program into the computer system and computer takes care of that particular program through the memory later on once they have been put into by the input output devices. So these are the few basic components of any new modern or older computer system which are required and which are essential for any computer system of today. Now let us look into more details of this particular von Neumann architecture. Are these 2 or 3 components sufficient? Probably we need something else. Okay, what we need, a sort of interconnection structure which basically couples all these 3 components together. Yes, that we will define later, but there need to be something else which is essentially required to keep some temporary data within the computer's central processing unit, and those are the operational units called registers, which once again are going to be electronic in nature, and they are the key component in any computer system. Many a times you hear the term called 32-bit processor, 16-bit processor. All these terminologies are related to internal register size of any computer system. Now let us explore further in von Neumann architecture how and what kind of registers will be required for any computer. Okay, the 3 components defined by me now can be clearly seen in this particular diagram. However, you will visualize there are 4 components given here. After all, this arithmetic logic unit and control unit form one basic component, and that is the central processing unit of the computer. This basically is the input output component, and this is the main memory. You can see there are several instructions placed in the main memory in the top half, and data is towards the end. Now let us try to look into more details how an arithmetic logic unit will be interfaced with the memory or input output device. Now you can see arithmetic logic unit basically is consisting of arithmetic logic circuits which will be performing the required operation onto the data, and memory buffer register whose job will be to interface it with the memory and get the data, required data from the memory as the time be, and an accumulator register AC which will be responsible for doing all the processing onto the data. And these 3 components together might be the arithmetic logic unit. There may be some more things required as far as arithmetic logic unit is concerned, but for the time being these are the 3 components which we are trying to portray in front of you in a very rudimentary machine. Now how a control unit will be looking to you in that particular category? The control unit will consist of few basic units by itself. The first one which is being visualized here is PC, program counter. As I was explaining to you the basic nature of an instruction execution, and that is sequential in nature. This PC basically is responsible for keeping track how the given instruction or which given instruction is getting executed. The IR basically is responsible for keeping track of which instruction is getting executed. That means the instruction which is getting executed will be loaded into register called IR or instruction register, and MAR, memory address register, will be responsible for issuing various addresses to the memory and indicating which address presently we want to refer to, and that will be basically referring to an instruction area if we are handling an instruction, or data area if we will be handling with the data. As far as control circuits are concerned, they will be responsible for issuing lots of control signals on getting various IR values, and these control signals actually will drive the whole arithmetic logic unit. Now coming back to the instruction execution, we want to define, I want to give you an example of instruction execution, but before I can give you an example, there are few basic things which need to be defined for an instruction, and the very first thing which is to be defined for an instruction is the instruction format, that is how an instruction looks like. You can visualize in the graphics that instruction consists of two basic things. The first place we are saying is OP code, we call it opcode in short, and it consists of 0 to bit number 3. So an opcode consisting of 4 bits, and basically this opcode will be responsible in indicating what kind of instruction we want to execute, whether it is an addition instruction, it is an subtraction instruction, or it is transfer of control instruction, or whatever instruction. That will be specified in this particular opcode. So obviously it will be a binary value of 4 digits. That means it can specify a maximum of 16 operations. The second component of it is the address. Now address basically is concerned with what location the data for the given instruction or given opcode is residing. So address will be specifying the data value. Now you may question that address field in the given instruction format is just 1. Obviously we need to specify only one data value for a given instruction, but how it is possible for addition? This particular thing is made possible by the given von Neumann machine by having one operand stored in the AC register in the arithmetic logic unit. So first operand will first be loaded into that AC register by a separate instruction, and then add instruction will be specified giving the required amount of data. So that is how he managed the addition operation from the given machine without having to compromise onto 2 addresses in a particular instruction. Had there been 2 addresses, the instruction would have become very, very large. The second thing which we would like to explore here is the integer format, because that is the normal data which we will be operating on, and for this particular given we are saying it is sign bit first followed by the magnitude of the given data. So this is what is the basic requirement for a given instruction. Now let us explore how an instruction will be executed, but before we can go for that, we need to know certain instruction codes so that we can follow them in our instruction execution example. Now the graphic shows the 3 basic instruction opcodes, and these are load accumulator from memory, we are saying 0001, store accumulator to memory, we are saying 0010, and add to AC from the memory, we will be specifying this 0101 for that particular case. Now let us look into how an instruction will be executed by the von Neumann architecture. The example which we have shown, basically you can see we are showing 2 components, the memory as well as the CPU registers. Now you can see this particular component is the address, and this address is unique for all the locations given over here. This particular portion of the memory is storing an instruction, whereas this portion of the memory is being used for storing the data. Now look into the address component. You can see the consecutive address locations are differing by just 1 bit. So all these 11 bits are the same, but the 12th bit is changing by a digit 1. Once again this particular thing will be changing by an addition of 1, and this is how we specify the addresses for consecutive location. They are separated by a unit 1. We add 1 to the previous address, we get the address of the next instruction, next location into the memory. Now let us explore further what this particular contents of memory locations are. You can see 0001, which was basically the load instruction, load accumulator register, and followed by the address. Now you visualize the address, I am reading it for you, 1001, 1000 and 0000, and fortunately that happens to be the address of this particular location. Okay, that means the data being specified by the load instruction is stored into this particular instruction. Okay, so in a sense I am instructing the computer that load the accumulator register with the value given in this particular memory location, and that is the instruction being given to the computer. How this instruction will be given to the computer? It will be given once again with the help of MAR and MBR registers. This is an MAR register which specifies the address to the memory, and this is the MBR register which basically gets loaded by the value first, and then later on that value will be translated by the arithmetic logic circuits to the accumulator register, and that was the instruction which we have asked our computer to execute. So this is the basic instruction execution step, which this is the first one. The second one you can see is add. So I have loaded the value of memory location into the location, okay, into the AC register, and then what I am specifying 0101, which is add instruction. Add the content of which location? 1001, 1000, 0001, which is the next location. So this will add on the value of given memory location, that is the second memory location, into the AC. So AC gets first loaded with some value, and then the addition takes place into the AC, and later on it can be in the next instruction the same thing will happen. Now it is the store instruction. So it will store back the given value which is available into the AC into the location specified here, which is the address of this location itself. So this location then will encounter a modified value which is going to be 5. Right now it is 2. So this is the way an instruction execution is going to proceed. So what are the basic, let us try to summarize the basic key terms which are associated with von Neumann architecture. The first basic term in that category is the binary digit, which is responsible for representation of operation code, which is also responsible for representation of character data, which may be ASCII or Unicode, and representation of numeric data. The second key term is the circuits, which in today's terms are the integrated circuits, which are associated with any von Neumann architecture of today. All these things basically lead on to some macro terms. For example, binary digit, that is bit, may take us to something called byte, and similarly other terms lead on to something called ultra large scale integration of integrated circuits. So similarly all these micro terms then can lead us on with various new terminologies which are associated with the von Neumann architectures, which are byte, ASCII, Unicode, and so on. ULSI, which is basically ultra large scale integration, word, which is just defined as equivalent to integer, the width of an integer unit. So let us summarize about what we have discussed in this particular session. In this session we have given you what are the basic components of a computer. In addition, we have also discussed about the concept of von Neumann machine. We have also detailed about the instruction execution, and we have given a specific example of instruction execution and how it is performed in a von Neumann machine. And in addition, we have given the details of the basic terminology. In fact, not the details, we have just referred to some of the basic terminologies related to von Neumann machine. Thank you for being with me.